Hi everyone, I am Prachi Agarwal from Ranveer Singh Institute of Technology. Welcome to our channel Learn Competitive Programming with CodeChef. If you are interested in competitive programming and want to learn and master data structures and algorithms, then this is a one-stop destination for you. Every week we'll post CodeChef problem explanations, conceptual videos on various programming paradigms, and also conduct live problem-solving sessions. But before we actually get started, here's a reminder to hit the subscribe button if you haven't yet already. Great! Now that you have subscribed, let's get started. Today we'll be solving the problem stick, which is a beginner level problem. Now let us see the agenda for today. So first we'll discuss the problem statement, then we will try to understand the concept behind solving the problem. We'll discuss the main observations that we can get from the problem. Then we'll also discuss some special cases. Then we'll discuss the steps in solving the problem, and finally we'll discuss the pseudo code and code it on the CodeChef IDE. So now let us go on to discussing the problem statement. In the problem statement we have n sticks and they are placed vertically on the ground. As you can see in the diagram that we have 5 sticks and they are placed vertically. So the vertical axis represents the height of the sticks and the horizontal axis represents the number of sticks. Now our task is to completely cut all these sticks and reduce the height of all the sticks to 0. And for that we are given a stick cutter. And in order to reduce the height of all the sticks to 0, we may perform 0 or more such operations. The conditions that we will keep in check while performing the operations are that we can choose an integer h above the ground and place the stick cutter there. Suppose we take h equals to 2 here. Now it is given that the part of the stick which is above the height of h will be cut off. That means if we choose h equals to 2, then for the first stick 3 unit heights will be cut off. For the second stick 1 unit height will be cut off. Again for the third stick 3 units height will be cut off. For the fourth stick 1 unit height will be cut off. And for the fifth stick, since there is no part of the stick which is above height h equals to 2, so nothing will be cut off from this stick. But the most important point to observe in the question is that in each operation we must cut equal lengths of the stick. That means if we have placed h equals to 2, if the cutter is placed here, then we are not cutting equal heights of the stick. Here we are cutting 3 units, here we are cutting 1 unit, again 3, again 1, so they are not equal. So we need to find that h such that we cut equal heights of the sticks in each operation. Now what we need to find in the question is the minimum possible number of operations such that we reduce the height of all the sticks to 0. So now continuing with the same example, let us see how we can do that. Now we can place the cutter at any position from height h equals to 0 to height h equals to 5, 0, 1, 2, 3, 4 or 5. But we need to remember two things. That we need to minimize the number of operations to reduce all the heights of the sticks to 0. And the second thing, that in each operation we need to cut equal number of heights. So if we place the cutter at h equals to 0, then we will not be able to cut equal height sticks. So for the first stick we will cut 5 units, for the second stick we are cutting 3 units, so they are not equal. Again for h equals to 1 and 2, the same problem will arise that we will not be able to cut equal height sticks. So ideally we can take h equals to either 3 or we can take h equals to 4, because then we will be able to cut equal heights of the sticks. If we take h equals to 4, then we can cut 1 unit height, and if we take h equals to 3, then we can cut 2 units of height from sticks 1 and 3, and the rest of the other sticks, they are already below h or up to the mark of h, so we need not cut anything in those sticks. But from 4 and 3, which will be the ideal one? If we choose h equals to 4, suppose, we have chosen h equals to 4. So now here, first time 1 unit height will reduce from stick 1 and 3, and the height of sticks 1 and 3 will become 4. Now again we will need to choose h equals to 3 in order to reduce the height of sticks 1 and 3 to 3. Because in each operation we can only cut equal heights. So that is why we will require an extra operation if we choose h equals to 4. So our number of operations will increase to 2. But if we choose h equals to 3 directly, then we will not need to do this extra operation, because then we can reduce these 2 units of height directly. So that is what we are going to do. We will choose h equals to 3, and this will be the first operation. So in the first operation we have chosen h equals to 3, and after performing this operation, the height of all the sticks will reduce to 3, 3, 3, 3 and 1. So the sticks 1 and 3 have reduced from height 5 to 3, as you can see here. Now again we need to choose h such that we are cutting equal height of sticks. So here now we will choose h equals to 1. So from sticks 1 to 4, we will cut 2 units of height from each stick. And after performing this operation, the height of the sticks will reduce to 1. So now all the sticks, as you can see, they have reduced to height 1. Now simply we need to place the cutter at h equals to 0, and all the sticks with 1 unit height will be reduced to 0. And the total number of operations, after operation 3 all the heights have reduced to 0. So the total number of minimum operations we performed are 3. So now what we can observe from the entire explanation of this test case is that initially we targeted the stick with highest height, that is 5, and we reduced the stick with highest height to the second highest height. We reduced sticks with height 5 to 3. Then in the second operation we targeted the second highest height stick, and including the first highest also, which have already been reduced to the second highest. So all in all we targeted the second highest sticks along with the first highest, and we reduced them to the third highest stick, that is 1. Now in the third operation, again we targeted the third highest stick, that is of height 1, including the first highest and the second highest, which have already been reduced to height 1, and then we reduced all the sticks to 0, from the third highest to 0. So, and this is how we amount to the minimum number of operations as 3. So after all the explanation, what can we conclude is that we are performing one operation for each stick of unique height, starting from the highest stick and gradually moving towards the lowest. So like in the example, we started from stick with height 5, and gradually we reduced the stick with height 5 to 3, then from 3 to 1, and then from 1 to 0. So for each stick with unique height, we performed one operation. So that means that the total number of minimum operations can be equal to the number of unique height sticks. So here we had 3 unique height sticks, that is 5, 3 and 1. So our total number of minimum operations were 3. Now what if we have sticks with equal height? So that was also explained in the example, that if we have equal heights, then we are performing the similar kind of operation for that stick. So that can be reduced in a single operation only. So we don't need to worry about that. We just need to find out the unique height sticks. So now let us see one more example and it will be clearer. Like here we have sticks of unique height as 5, 7 and 8. Again we have 3 unique height sticks in this example. So the total number of minimum operations will again be 3 in this case. And what will be our flow? Our flow will be, we will target the highest stick first, that is stick with height 8. We will reduce the sticks with height 8 to stick with height 7. Then we will target all the second highest sticks along with the first highest, which have already been reduced to the second highest. And we will reduce all these sticks to the third highest, that is 5. Now we will target the third highest stick in the third operation, that is 5, and including the first highest and the second highest sticks which have already been reduced to the third highest. And we can reduce all these sticks to 0 in one go, because all the sticks now would have been of height 5. So that is how we will come out to be the minimum number of operations will be 3 in this case, and all the sticks will be reduced to 0. Now let us see the input, outputs and constraints. So the first line of input is the number of test cases, then the number of sticks, that is n, and we are given an space separated integers which contain the height of the sticks. Then for output we need to print the minimum number of operations needed to completely cut all the sticks and reduce the height to 0. Then the constraints. So the number of test cases are 50, not very high, but the number of sticks that can be there are 10 to the power 5. So that is a huge number. And also the height of the sticks are given as highest 10 to the power 9. So that is also a huge number. We will need to code this in a time complexity less than n square, because n square will not get accepted for such kind of constraints. Then this one is the part that we need to notice, that for height of the stick, the height of the stick can also be 0. So what do we do in that case? Will we include it in the number of operations? So as I explained earlier, that we need to find the unique height sticks, and the number of unique height sticks will be the minimum number of operations required to reduce the sticks to 0. But if we have the height of the stick as 0, then what are we doing in this question is that we are reducing the height of sticks to 0, but we are already given a stick which is of height 0. So we don't need to perform any operation for that stick. So even if in the unique set 0 will be included, because 0 is a unique height. So 0, 5, 7 and 8. This will be our set which contains the unique height stick. But we will not include 0 in the number of operations, because we don't need to perform any operation for this stick. So again our answer will be 3 in this case. We can either ignore 0, or if we include 0 in the set, then we can always take our answer as 4 minus 1. So the length of the set is 4. So our answer will be 4 minus 1 equals to 3. Now let us discuss the steps involved in solving the problem. So I'll discuss two approaches with you. In the first approach, to find the number of unique height sticks, what we can do is that we'll sort our array which contains all the heights of the sticks, and then we will count the height as unique if it is not 0 and not a repetitive value. So what does this mean? Suppose we have a array with these heights 0, 5, 7, 0, 7, 5. These are the height of the sticks. So we need to choose the unique height sticks only, and we need to ignore 0, because 0 is already 0, so we don't need to perform any operation on that. So here the unique height of sticks which are not 0 is 5 and 7, and our answer for the minimum number of operations is 2. But what is the purpose of sorting the array? So if you sort the array, see like 0, 0, 5, 5, and 7, 7. So what advantage have we got? That we have got the equal height sticks together. So it will be easier for you to select the unique height of sticks, that is 0, 5 and 7, and then you can ignore 0. So this you can achieve in order of n time complexity, and the sorting time complexity will be order of n log n. So the total time complexity in this approach will be order of n log n, and we will see the pseudocode for the same in a while. Then you will understand this approach better. A second approach that you can use for solving the problem is to use set data structure. So what is a set data structure? Suppose we have an array which contains repetitive elements 2, 2, 3, 3. So if you convert this array into a set, then it will contain all the unique elements. So 2 and 3 are the unique elements, so our set will contain 2 and 3. Now what is the advantage of using a set is that it uses a hash table, and in hash table if you search any number, then it takes order of 1 time complexity. So if you use a set for solving this problem, then you can solve this problem in total order of n time complexity. How? Because each time you will place the unique elements in the set. Suppose you have this array 0, 0, 5, 5, 6, and suppose take 5 again. So this is the array that you have. Now you need to convert this into a set. So each time suppose that in the set you have placed 0 from the first index. Then you move to the second index. Now you will check that if 0 is present in the set or not. So this is our set, and you will need to check that if this value is already present in the set or not. So this check will take order of 1 time complexity in a set. But if you use an array for the same thing, then it will take order of n time complexity, and that way our time complexity will increase to order of n square if we do not use a set in this approach. So it is important to use a set. Then you will just need to check in the set that if the set contains 0, then our answer will be the length of set minus 1, because we are not including 0 in the minimum number of operations. But if the set does not contain 0, then our answer will be the length of the set, that is the minimum number of operations. Now let us see the pseudo code for the approach where we are not using a set and we are sorting the array. So first we will discuss the variables used. The variables are: A denotes the array which contains the number, the height of the sticks, and n is the number of sticks that we have. Then I and count are the counter variables. So I we have used for the loop variable, and count is the counter variable. And temp is a temporary variable which will keep a check for the repetitive values in the array. So initially our count will be 0, and this count we have taken to count the unique height of sticks. And then we will sort the array. After sorting the array, let us take an example, and we'll also do the dry run of the example along with the pseudocode. So suppose we take the array as 1, 2, 1, 4. So and let us include a 0 also, so that it will be better to understand for you. So after sorting this array, we will get 0, 1, 1, 2 and 4. Now we will iterate from 0 to n minus 1. These are the index 0 and n minus 1. These are the indexes of the array, and we will need to iterate for each of the elements present in the array. Then we will check if a of I is not equals to 0 and a of I is not equals to temp. So initially let us make temp as minus 1, because initially we are not storing anything in our temporary variable. So for the first element in the array, this condition will become false, because a of I is equals to 0. so we will not enter this if condition. Then we will move on to our second element, that is 1. Again, if a of I is not equals to 0, so this condition is true. If a of I is not equals to temp, so 1 is not equals to minus 1, so we will increase our count. So the count will increase from 0 to 1 because we have encountered a unique element here, that is 1. That is why our count has increased to 1. Now we will update temp as a of I because we have already counted 1 once as the unique element. We do not want to count it again. So for all other appearances of 1 in the array, we will not count it. So that is why we have updated our temporary variable. Now next time, then it will point to the element at second index, that is 1. Then again we will check if a of I is not equals to 0 and a of I is not equals to temp. So this condition will become false because a of I is not equals to 0, but a of I is equals to temp because we have updated our temp as 1 and this element that is also equals to 1. So this time we will not enter this if condition. So I hope that you are getting my point, that we will only enter this condition in case of a unique element, but in case of repetitive values, we will not increment count. So that is the purpose of sorting the array here. Then again we will move to the element 2. Now we will check if a of I is not equals to 0, so this is true, and a of I is not equals to temp, this is also true. So that means this is a unique element that we have encountered. Again we will increment count from 1 to 2 and also we will update temp. So we have updated temp to 2. Now suppose if here more 2's must have been there, more appearances of 2 must have been there in the array, then again the if condition would have become false each time and this 2 would not have been counted. Then at last we have 4. So again this condition will become true because 4 is not equals to 0 and 4 is not equals to temp, that is 2 in right now. So this condition will become true and count will be incremented once again because 4 is a unique element. So we have incremented count and again we will update temp with 4. So now our array is over, means we have reached the last element. So now we will come out of the loop and what we'll print, we'll just print count because count has counted all the unique elements and we have got our answer, that is the minimum possible number of operations for reducing all the heights to 0. So this is the pseudo code, guys. Now let us code this into the CodeChef IDE. So guys, today I'll code it in Python and I have already taken the inputs. As you can see, we have taken the input for the number of test cases. Then for each test case, we are taking the input for the number of sticks and the array which contains the height of all the sticks. Now after that, we'll define some variables, that is count, which will count the unique height sticks, and we will declare a temp variable, that is a temporary variable, and we will initially keep it -1. Now we need to sort the array. So we'll just use a function to sort the array. This will take order of n log n time complexity. Then after that, we will run a loop for each stick. So it will be from 0 to n. So this range function, it will run the loop from 0 to n minus 1, that is for each element present in the array. Now we will just check that if a of I is not equals to 0, because we need to ignore 0, we cannot count it in the minimum number of operations, and a of I should not be equal to temp. That is, we are doing this because we need to count the unique elements, that is unique height. So that is why we are taking this if condition, and I have already explained this to you with an example in the previous slide. Then after taking this if condition, inside the if condition we will increment count with 1. Because if we find a unique element, then we need to increment count with 1. And also we need to update our temporary variables to the unique element that we have found, so that it is not counted again. Then after that, after we come out of this loop, we'll just need to print count, which will be our answer. So count will be the minimum number of operations that we required to reduce the height of all the sticks to 0. I'm sorry, the range here is capital N, so let's change that. Now let us submit the code and check if we get an accepted answer. Great guys, we have solved the question, we have got an accepted answer. Now I hope that you will be able to code this question in any of the programming languages that you want. If you enjoyed the video, please like it, share and subscribe to our channel, and also if you have any suggestions or feedback, please post it in the comment section below.